Good morning. I'm Kavitha M, Assistant Professor in the Department of Civil Engineering, Rajagiri School of Engineering and Technology. And today I'm going to take a lecture on materials management, which is a topic in Module 5 for the final year civil engineering students for the subject CE404 Civil Engineering Project Management. So I'll just give you a brief introduction. What is materials management? So whenever there is a project and when you're dealing with project management, materials form a very important part of the project. And so we require a very integrated approach towards the management of materials. So you require whatever materials are associated with your project, there should be an efficient flow of the materials to the organization, through the organization, and out of the organization to make sure that you're making use or making the best possible use. You're making the optimum use of the materials. And so we have to study materials management to make sure that this is taking place. So whenever you're talking about materials, whatever be the nature of the project, as civil engineers, we'll be studying about construction project, but whatever be the nature of your project, you require maximum utilization of the materials and minimum expenditure on the materials. And for this, materials management is important. So what does material management deal with? Material management deals with the acquisition, storage, control and disposition of two types of materials, direct materials and indirect materials. So when you're talking about direct materials, they are materials that are directly connected to your activity, like specific inputs like raw materials. And when you're talking about indirect materials, they're actually materials that are required for everyday operations, not specifically for a particular activity, but they're required throughout the project. So these materials include tools, spare parts, etc. So material management has to deal with the management of both these type of materials. Now, what is the need for materials management? Materials come and go. As you know, materials come and go in a project. So what is a specific need that arises for materials management that you have to be clear about? You have to understand that 50 to 80% of the total assets involved are materials. And then there are a lot of complications that are going to arise, whether it is dealing with raw materials or you are dealing with the components, or maybe you are dealing with some sub-assemblies. So that calls out for systematic management of these materials. And that is why you require materials management. Now, the materials, they have to be handled, they have to be procured, they have to be stored carefully, handled carefully, they have to be distributed to different locations. And so you need a particular a team to manage all these things, and that is why we require a materials management team for a project. So let's look into the objectives of materials management. The objectives of materials management is to reduce the cost of materials through the use of scientific tools and techniques. You have to ensure there is uniform flow of materials for the production. It should not happen that the production suddenly stops because of your mismanagement of materials and you've not procured enough materials, or there is a shortage of materials at site. That should not happen. Production should go on smoothly, and for that, a uniform supply of materials should be available, and that is one of the objectives of materials management. You have to ensure the availability of the right quantity as well as the quality of the materials at the right time. There are three rights here: right quantity, right quality, and right time. You have to make sure that materials are available in adequate quantity with good quality, and they are available exactly when they need it. And that is an objective of materials management. Now, you always have to establish and maintain good supplier relationships, because one project that you're undergoing or maybe you're doing right now might not be the only project that you're going to do in your life. You might have to carry out more projects, bigger projects than the one that you're working on right now. And so it's important for you to establish and maintain good relations with the people who supply the materials. And if you are on the mismanagement, or if you are on a mismanaging side of things, it so happens that you spoil your relationships with the suppliers, and that should not happen. And so you should have good materials management to establish and maintain good supplier relations. Now, by an efficient materials management, you ensure that the department costs are lower, customer service is better, and you are able to practice your ethics, and you're able to maintain your standards. Now we come to another very important topic in materials management, which is inventory. For many of you, you might have heard it in places, but you might not exactly know what inventory is. So inventory comprises of materials in transit, materials in process, finished products, and stocks lying in companies' showrooms and distribution centers which have not been sold. That is, they're finished but they have not been sold. This is what is meant by inventory. So the part of the company is, except for sales, the part of the company is over, and what is remaining is that the company has to sell them to the customer. Now, inventory control is a very important topic in materials management. Inventory control is the process of ensuring that appropriate amounts of stock are maintained by business so as to be able to meet the customer demand without any delay, and you have to keep the cost associated with holding stock to a minimum. That is, the customer should be satisfied. If the customer comes and asks you for your product, you should be able to deliver without having any delay, but at the same time, you should not hold your stock so long that it will cost you a lot to hold stock. That is, if you are storing, let's say annually you have 20 customers who might be coming and buying this product from you, your product from you. So you don't need to stock 100 pieces of inventory, because you know that annually about 20 customers are coming, because if you store more than what is required, the storage cost will increase, and that will get you and your company at a loss. And so you have to keep the costs associated with holding stock to a minimum, but at the same time, when a customer comes to you, you should be able to meet their demands without any delay, known as inventory control. Now, what are the functions of inventory control? You have to separate or isolate different operations and make them independent so that each operation can be performed economically. You have to maintain smooth and efficient production flow. These are all the functions of inventory control. You have to purchase in desired quantities to nullify the effects of changes in prices and supply. So it happens that price rise during the project takes place. And when you're procuring your materials, if it so happens that you procure your materials at a time when the cost is really high, then you might you might be actually pushing the boundaries of your budget. So you have to make sure that you purchase in desired quantities. You have to purchase materials in desired quantities so that you nullify the effect of changes in prices and supply. That is, you might have to buy it at a time when the price is low also, so that even if you buy some products, some materials when the price is high, these both will balance each other. You have to keep a process continuously operating, and that is why you need to do inventory control. Then you have to protect the inventory from losses due to improper handling, storing, and unauthorized removal from stores. Also, pricing of all materials supplied to stores should be done based on inventory control. That is, you decide the price of your product based on how you control your inventory. Now, there are different types of inventories, direct inventories and indirect inventories. This is a small flow chart that shows the different types of inventories. Direct inventories involve production inventory, work in progress inventory, finished goods inventory, MRO inventory, or different miscellaneous types of inventory. Indirect inventory deals with transportation inventory, decoupling inventory, buffer inventory, seasonal inventory, lot size inventory, and anticipation inventory. Lots of these terms will be new to you. So we will be dealing with them a little bit more in detail. So direct inventory, you just saw the subdivisions of direct inventory. It includes all the items that are directly used for production or manufacture and are part of the goods or services produced or provided. So that is, you use those materials for the manufacture, and the material that you're delivering to your customers, these materials form a part of those products. So production inventory, these include raw materials, components, and sub-assemblies that actually become a part of the product, a part of the finished product. Then a work in progress inventory are components which are semi-finished. That is, they are in the process of getting finished. They are neither raw material nor are they finished goods, but they are in the process of getting completed. Finished goods inventory are the final products. They are ready to dispatch to the customers or the distributors. MRO stands for maintenance, repair, and operating items. Like always, you need some items that are required for maintaining and repairing and operating items, like spare parts and consumables. And these also form part of your inventory. These also form part of your direct inventory. Miscellaneous inventory involve scrap, obsolete, and unusable items. They also include office stationery, etc. On to indirect inventory. Indirect inventory are the items or goods that are needed for production or manufacture, but they're not part of the goods or services that are produced or provided. For example, you use oils in your product, you use coolants in your product. However, you are not going to be or they are not going to be part of the product when the final product is delivered. They're only used during the production stage or the manufacture stage. Such inventory is known as indirect inventory. An example is transportation inventory, items that are currently in transit. Buffer inventory. Now, what happens is sometimes some situation might arise where you require protection against uncertainty. Uncertainties in sort some natural calamity, or what is happening right now, like in the case of COVID, or there might be some financial crisis, there might be a recession, there may be a lot of things that happen in the world, and so you need some items that need to be purchased as protection against uncertainties of supply and demand. That is, you don't know if this material is going to be available 2 months from now, so why not buy them right now? That is known as buffer inventory. Decoupling inventory are items that are required to decouple or disengage parts of the production system if you want to decouple them, or if you want to separate two different parts of the production system. Seasonal inventory are items that are required to meet high seasonal demands. For example, certain items will have very high demand as pertaining to the particular season. If it's a festival season, there will be a certain item that will be more in demand, and so you have to procure these items keeping in mind the high seasonal demands. Especially in a country like India, there are festivals around the clock. There are festivals every month in different parts of the country, and you know that at different times, for example, if it's Diwali season, firecrackers will be in high demand. So something like that. You need to procure things keeping in mind the seasonal high demands. You have a lot size inventory. So lot size inventory is something like this. You want to purchase a particular item, 5 units of a particular item, but then you go to the shop to procure this material, and you see that if you procure 8 of them, you will get a discount. So keeping this discount in mind, you will purchase, or you would want to take advantage of it, and even though you actually require only 5 units, in order to take advantage of the discount, you procure the lot size, that is all the 8 of them, in order to take advantage of the discounts that are provided by the provider or the supplier. That is known as lot size inventory. The extra material that you have with you for the sake of obtaining the discount is known as lot size inventory. Then there is something known as anticipation inventory. Anticipation inventory is items that are stocked in anticipation of an event. You are anticipating that the public would want to buy your product during this time, or you are anticipating that there is going to be, for example, suppose you're going to be deciding that there is going to be very heavy rainfall in the next 2 months, and so people would be, and you're anticipating that people would be wanting umbrellas and you're going to produce umbrellas. So these are items that are stocked in anticipation of an event. You're not sure, that event has not happened yet, but you're anticipating that this event is going to take place. And so items that are stocked like that are known as anticipation inventory. Next, we come to the topic of economic order quantity, or EOQ. So economic order quantity is also known as an economic lot size. The concept of EOQ stems from two questions related to the inventory control, and that is how much to buy. That is, you have to decide how much material you require or you would like to buy, and when to buy, whether to buy it now or to wait, and you have to weigh the risk of stock out versus the cost of holding extra inventory. If you buy it now, you would have to hold extra inventory. You would have to have the storage space for holding extra inventory. If you wait, you might face the risk of stock out. That is, that particular material might run out of stock and then you won't have anything. So you run that risk of stock out. But if you purchase now, you have to find out storage space for keeping that extra material. So these are the two questions that come into your mind when you are talking about the concept of economic order quantity. So let's look at it in detail. How much to buy? That is the costs involved. You're looking into the costs involved. There are different types of costs involved. One is known as the ordering costs, setup cost, and carrying or holding cost. That is expenses incurred to create and process an order to a supplier. That is the cost, it increases with the number of orders. That is basically the expense used to process an order is known as ordering cost. It increases with the more the number of orders, greater the ordering cost. That is, it does not depend on the lot size. For example, even if you're procuring 2 units of a material, or you're procuring 100 units of the material, your ordering cost would be the same if you're ordering it together. That is, 2 units of the material as well as 100 units of the material, the ordering cost would be the same, because you're processing it in a single, you're processing it as a single unit. So, but if you want to purchase 100 units and you are going to purchase it in units of 2, you would have 50 orders going through. So your ordering cost would be 50 times than if you had ordered it 100 all at once. So that is what is meant by ordering cost. It increases with every order. Then setup cost. Setup cost is the cost incurred to get an equipment ready to process a different batch of goods. It's the cost of stoppage of production during setup time and is independent of the quantity to be produced. So there is every equipment would be ready to produce a batch of goods, but after they produce a batch of goods, you have to switch off that material and then get it ready for the next batch. So there is a small amount of time when no product is being produced by that particular equipment, and that is going to cost you, because time is very costly to you. So that is known as the setup cost. Every equipment has it. There is going to be a time gap between 2 different batches of goods being provided into this production unit, and so that cost of stoppage of the material to process a next batch of goods is known as setup cost. And then you have the carrying or the holding cost. Now, we have discussed about carrying or holding cost. Carrying or holding cost is the amount that you have to pay to keep or to hold your inventory. That is, you have the inventory with you, you need to store it somewhere, you need a go down for it. So you need to rent out a go down, and you have to more the volume, more the storage space required, and you have to pay for it. And so that is known as the carrying or the holding cost. So these are the 3 costs that helps you decide how much of the material you are going to buy. So here is a small comparison. If the quantity that you're going to buy is small, then you will have to send out a lot of orders. So the ordering cost would be high, but the carrying cost would be low. The carrying cost would be low because you're ordering a small amount every time. So the amount of storage space required would be less. However, since you're sending out a lot of orders, ordering cost would be proportional to the number of orders, and so ordering cost would be high. At the same time, if a larger quantity is chosen, then the ordering cost would be less because the number of orders sent would be lesser. If you are purchasing 100 units at one single time, then ordering cost would be going only once. Rather than sending 50 orders of 2 units each, you're sending just one order of 100 units, and so your ordering cost is going to be less. However, the holding cost is going to be high because 100 units are going to come. You need space to store it. So you need the storage space, you need to rent out the storage space. So carrying cost would be high. So this is a small comparison between what happens if small quantity is chosen and what happens if large quantity is chosen. The next question is when to buy. So once the decision on how much to buy, you have come up with the decision on how much to buy, the next decision is to decide when to buy this. So the available virtual stock. Virtual stock means the quantity is in hand plus the quantity on order minus the demand in hand yet to be complied to. That is the amount of products that you have in your hand plus the amount that you're going to procure minus something that demand means you have already been given orders by your customers, so you have to give it to them. So that is the available virtual stock. Now that is compared with a certain level of stock called order point to see whether it is time to buy. So I'll explain it using this graph. So these are the units in stock and this is the time. Now you have a lot of units in stock. Now as time progresses, your units are going to reduce, and then at a particular point you decide to order more material. Now the time taken for the material to reach is a little beyond this point. So by the time the material reaches, your units in stock are again going down, and by the time your units reach what is the quantity what is known as safety stock, then your order that you have given reaches you and suddenly your units go up, and again the same story repeats. So there is an order point, that is, you know that if you order at this point, by the time your stock reaches your safety stock, this order would be delivered and you would again have units in hand. So that is what is known as order point, and you should have an idea of what is the order point in order to make sure that you never run or you never go below your safety stock. So there is a concept known as lead time. The lead time was shown in the previous graph also. The time interval between the placing of an order and receipt of the goods. That is, you decide to place an order at a particular time, and after that certain number of days have to pass for you to get that particular order. So the time gap or the time interval between placing an order and receiving an order is known as lead time. So lead time consists of the time required by the stockist. Then there is work. You can't simply, it's not like buying some material out of Amazon or Flipkart. There needs to be, when you're working with a large scale project, there needs to be some tendering work done. Tender processing time is required. Then transportation time is required, then inspection time is required, because you're dealing with serious business. It's not for your personal use, it's for the company. So you need to do a lot of things before they actually come to you, and that is why there is maybe it might take 3 or 4 weeks for them to deliver the order. So again, this is the graph. This was the same graph that I'd shown earlier. So this is the order point and this is the safety stock. So the time difference from your ordering point to the acceptance of the goods, the time difference between the order point and the acceptance of the goods, that you see this horizontal line here, is known as the lead time. And once the goods have accepted, your stock goes up and this story repeats. So this is what is known as lead time. Now we are going to look at a few conditions under which the concept of EOQ is applicable. So item is replenished in lots or batches either by purchasing or manufacturing and is not produced continuously. That is, you have to keep on replenishing. That is when this concept of economic order quantity has any application. Because if the material is something, if your product is something that is getting continuously produced, then you don't need to order anything. It just happens, the process is smooth. So economic order quantity applies only when the item is replenished in lots or batches. That discreteness should be there. Only then the concept of EOQ is valid. Then sales or usage rates are uniform and are low compared to the rate at which the item is normally produced, so that a significant amount of inventory is resulting. So the usage rates are low compared to which the item is produced. The rate at which the item is getting sold is lesser than the rate at which the item is getting produced. Only then inventory results. That is, inventory means your materials that are not yet sold. So materials that are not yet sold arise only if the rate at which they're getting sold is lesser than the rate at which they're getting produced. So only then the concept of EOQ comes into play. Only then you need to decide how much to produce, when to produce, when to buy. All these thoughts need to come to you only when you're facing a problem that the sales is not going at the same rate as the production. EOQ is not applicable to products with limited tool life, short shelf life, economic use of raw materials, and similar other constraints. So EOQ has not taken, when we explained the concept of EOQ, we did not consider these shortcomings that can be happening to different materials like limited tool life, short shelf life, economic use of raw materials, and etc. and or other constraints that are placed when we are dealing with production. Now, there are different techniques of finding the economic order quantity. Three of them are the mathematical approach, tabular approach, and the graphical approach. We'll first deal with the mathematical approach. So before dealing with the mathematical approach, we'll just look at the definition of EOQ. EOQ is the quantity whose material procurement cost is equal to the inventory carrying cost. That is, the procurement cost is equal to the carrying cost. That is what is known as an economic order quantity. Or there is another definition. EOQ is the quantity whose total cost, when you're talking about total cost, it's the ordering cost or procuring cost plus the carrying cost is a minimum. That is, you want the minimum cost when you're talking about economic order quantity. Now, we know that total cost is ordering cost plus carrying cost. Let D be the demand rate. That is the number of units that are getting sold every year. Let D be equal to the number of units that are getting sold every year. Let A be equal to the ordering cost. That is the amount of rupees spent per order. Let Q be equal to the order quantity. Now Q is the number of units in one lot. That is, usually products get sold in lots. So the number of units per lot is equal to Q. So the total number of orders placed every year is equal to D, that is the demand, divided by Q. That is the number of units sold divided by the number of units per lot. So that will give you the total number of orders on the number of lots placed. That is the total number of lots that are ordered every year is equal to D divided by Q. So ordering cost or procurement cost per year is equal to the number of orders placed in a year into the cost per order, that is A into D by Q. D is the number of units that are getting sold every year. Q is the number of units per lot. So if you want to know the total number of lots that are getting sold every year, total number of lots getting sold every year is D by Q. Now the cost, ordering cost per order per unit is A. So A into D by Q would give you the total ordering cost or procurement cost per year. Now look at this graph. Here, this is the at one point, this is the you're assuming the demand is at a uniform rate. That is, at one point the demand is Q, and at another point the demand is 0. And so we are assuming that there is an average demand per year, and so the average demand is 0 plus Q by 2. That is Q by 2 throughout the year. Average inventory required would be Q by 2 throughout the year. So at one point the demand is 0, and another that is another point. So what we're trying to prove here is that, let's look at this graph. Here, assuming that the demand is at a uniform rate, the average inventory required would be 0 plus Q by 2, that is Q by 2 throughout the year. That is, when the inventory level units are maximum, the demand would be 0, and when the demand is when the order quantity is 0, demand would be maximum. So we are assuming that the average inventory required is an average between these two values, and that is equal to 0 plus Q by 2, that is equal to Q by 2 throughout the year. So the inventory carrying or holding cost is expressed as a percentage of the unit price of an item. So inventory carrying cost per year is equal to H into Q by 2, where H is the annual cost of carrying a unit item. That is, and Q is the order quantity, which is number of units per lot. That is, at one point the go down would have to carry full would be in full capacity and would have to carry all the Q units, whereas at one point there would be 0 units in the garage. So we are assuming that throughout the year, we are taking an average value. Throughout the year, we are assuming that there is an order of Q by 2. And so throughout the year, we take this uniform rate of Q by 2 and multiply it with the inventory carrying cost H. And that would be the inventory carrying cost per year, H into Q by 2. So total cost is the ordering cost plus carrying cost, that is equal to AD by Q plus HQ by 2, which we found out the ordering cost as well as the carrying cost earlier. So for optimum Q, we need to find the particular value of Q which will minimize the cost. So to minimize the cost, we have to differentiate it. So differential of total cost with respect to Q would be equal to 0, and therefore we get minus AD by Q squared plus H by 2 is equal to 0. That is, Q is equal to root of 2 into A into D divided by H. So to remember this formula, this is the economic order quantity. So that was the mathematical approach. Next, we are going to see a simpler approach, which is the tabular column approach. In tabular column approach, we select a number of possible lot sizes to purchase. You determine the total cost of each lot size chosen, and then look at the table and select the ordering quantity that minimizes the total cost. That is, you write everything down in a table, and from the table, you will take the ordering quantity that minimizes the total cost. You will check for various possible lot sizes. That is tabular column approach, not that complicated. Then you have the graphical approach. This is a graph that you've studied while you were studying your crashing in module 2. Approximately something like that. So here you can see that the holding cost as the ordering quantity is increasing, the holding cost is increasing, whereas the setup cost or order cost is going down. And so you have an optimum between the holding cost and the setup cost. This is the total cost. The yellow curve is the total cost, and you will get the minimum value of total cost from this curve. So it's an optimum between the holding cost and the order cost. This is a graphical approach that we've already discussed in module 2. Now, we have discussed ideal case scenarios. However, the reality is far from being ideal. You have a lot of deviations from the typical pattern of economic order quantity, and we're going to discuss three particular variations from the typical pattern of from the typical pattern of the economic order quantity. They are quantity discounts, which involve cost comparison approach and price break approach, deviations of purchase lot sizes from the theoretical EOQ, and EOQ model with stock outs allowed. So first let's check discounts. In quantity discounts, we are first going to check the cost comparison approach. So we have made an assumption in EOQ calculations that price per unit remains constant irrespective of the quantity that has been ordered. Now, you know that that is not true. You know that whenever you go to a wholesale shop to procure your materials, greater the materials that you procure, lesser the amount they will collect from you. They will give you a discount. If you say that you want 5 units, they'll say if you take 8 units, we will give it to you at a lower price. So we will give you a discount of 20%. If you are procuring 5 units, your discount would be say 5%. But if you're procuring say 8 units, your discount would be 20%. Would you be wanting to take the 8 units, or would you be sticking on to your 5 units? So basically, in actual practice, since vendors offer discounts for bulk quantity purchases, always EOQ, you will calculate all your EOQ using a mathematical approach and your graphical method and everything, and you go to the shop and everything goes upside down because the vendor has suddenly decided to give you a huge discount if you procure a little bit more extra. And that is a variation from the typical pattern of EOQ. So there are two cases in front of you. If the optimum quantity as per your calculations, you have all calculated it in your notebook, you have found out the economic order quantity using graphical method or mathematical method, you have differentiated, you have found out the economic order quantity. But if the optimum quantity as per your EOQ calculations is greater than the minimum to earn discount, then fix your quantity as EOQ, you have no problem. That is, you have calculated your EOQ to be 10 units, and you go to the vendor and the vendor says if you procure 8 units, I'm going to give you 50% discount. So if you buy anything greater than 8, he's going to give you that 50% discount. So you fix your quantity as EOQ. You have no problems there. You are fine. The second case is if the optimum quantity as per EOQ calculations is less than the minimum to earn the discount. That is, your EOQ is 5 units. You go to the vendor and the vendor says if you buy 8, I'll give you a 50% discount. So you have two options in front of you. Whether you stick to your EOQ and buy only 5 units, or if you want to go and purchase those 8 units and avail that 50% discount. So here 3 costs are to be considered. Payment to the vendor, if discount is availed, payment will reduce. So whether you want to go for EOQ or whether you want to go for the minimum quantity to avail the discount, you have to think about these 3 costs. One of them is the payment to the vendor. So definitely, if you're availing the discount, you would have to pay a little lesser. Ordering cost. You have to understand that fewer the orders, reduction in the ordering costs. And the third one, inventory carrying cost. That is, you're going to buy a little bit greater than your EOQ, means that you also have to find out money to carry that inventory. Larger the inventory, larger the carrying cost. So all these 3 should run through your mind when the vendor is smiling at you and telling you that he'll give you a 50% discount. You should think and decide whether you should stick to your EOQ or whether you want to avail the discount and procure a little bit extra. So one has to weigh the total of 3 costs for EOQ lot size before actually accepting or rejecting the discount. So basically, this is what happens. This is a variation that happens to your economic order quantity calculation. You calculate everything as per the ideal case, but you go there and you see that they're giving you discounts. Your calculation topples over. Now, another discount that is available is price break approach. That is, the cost comparison approach was limited to the case when only one discount was offered. Now, that is not the scenario usually. It's possible to determine the EOQ with any number of successive discounts taking effect as quantity purchased increases. That is, the vendor is telling you that if you buy 8 units, I'll give you 50% discount. If you buy 10 units, I'll give you 75% discount. So as there is even the discount rate is varying as the quantity purchased is increasing. And so these are known as price breaks. So price break approach can also be taken into consideration to determine the EOQ. Here, earlier we were dealing with the variations in EOQ that were related to the quantity that was being purchased. Now we are going to deal with deviations of purchase lot sizes from the theoretical EOQ. So you've calculated your EOQ and you've got that your EOQ is say 6 units. You go to the vendor tells you, sorry sir, I sell in batches of 10. I sell a box of materials, each box has 10 units in them. So you are not able to purchase your EOQ, which was 6 units, in spite of the fact that you have calculated everything and you got 6 units, but you go to the vendor tells you that he's put everything into a box, separate boxes. Each box consists of 10 units. So you either buy one box or you buy nothing at all. So even though your economic order quantity is 6 units, you might have to end up buying 10 units. So how do you decide whether to go for it or not? You have to decide it using the graphical approach. So you can see the total cost curve here. This is the least total cost. Now what they're saying is that even if your order quantity is slightly varied between these two vertical lines that I'm showing you, between these two vertical lines, even if you vary your order quantity in between these two vertical lines, the variation in the total cost is very little. You can see it's an almost horizontal line here, though not completely horizontal, it's very flat, and slight changes are okay. So you need to know the limit up to which your order quantity can vary from your EOQ, such that your total cost is not getting affected by much, so that you can adjust the lot size that you're going to purchase. So that also you have to be clear about when you're going to purchase a material and you're following the concept of economic order quantity. Now, economic order quantity with stock outs allowed. Stock out means running out of stock. So stock out can lead to two scenarios. One is back orders. If you're very good at what you're doing, then customers come and place orders even though they know that you have no stock with you. For example, if you take the certain cars, you can see that people are actually having to book the cars and wait for 6 months before having it delivered, because that lot is actually not available, or the products is not readily available. This is known as a stock out, and it leads to a back order. Back order means placing an order for a product that is temporarily out of stock. So that is one case that can happen if a stock out happens. That happens if you're really good. Another case that happens is lost sales. Now, if someone wants a car very badly and they want it right now, and they come to your showroom and they ask you to give them a car, and you are out of stock, and you tell them, wait for 6 months, our next car will be out in 6 months, that person might not be patient enough. That person might not be ready enough to wait for 6 months to get your car. Instead, he'll go to the adjoining showroom and buy a car from another manufacturer. So this will lead to loss of future sales when a customer does not return. It also leads to loss in goodwill. That customer will go to other people and tell them that they do not provide cars on time. It will take a long waiting time. You better go to the other person, and you will lose a lot of goodwill if stock out happens. So since back orders and lost sales are difficult to estimate, service levels have to be frequently specified. So the management, so when you're fixing your economic order quantity, you have to keep in mind that stock out should not occur, or the management may feel that stock outs should not occur more than 2% of the time. So next we come to ABC analysis. ABC stands for always, better, control. So before beginning with ABC analysis, we have to understand how this ABC analysis came into the picture. So Vilfredo Pareto, an Italian economist, while studying wealth and income distribution, found that a large percentage of the total national income and wealth, about 80% of the total national income and wealth, was concentrated in a small percentage of the whole population. That is, 20% of the people were holding 80% of the wealth. So the theory of significant few and insignificant many came into the picture. So this 80-20 relationship holds good in most cases of inventories also. That is, what they're saying is, for a company, let's take Maruti for example. Now Maruti manufactures cars in all variants. They have high-end variants, as well as they have the small hatchbacks that will be lesser in cost. Now, what they mean is that by selling maybe 50 small hatchbacks, they would not get as much money as selling maybe 2 high-end models of their cars. So one particular high-end model, if you invest, that is lesser quantity of a high-end model will give you more returns than a large number of quantity of your small-end models. About 20% of the inventory is responsible for 80% of the revenue. Okay, and so this leads the studying inventory value. This leads to the idea of studying such inventory value to find out where you have to invest to get the money. So let's just look at a graph. You can see the graph here. So here you can see this is the percentage number of items and this is the total revenue on the y-axis. You can see that 80% of the revenue is given by 20% of the items. So this 20% of the item fall under class A. So class A comprises of high value of the total inventory with very few items. So 70 to 80% of the revenue is given, but at the same time only 20% items need to be manufactured. When you go to class B, class B is a medium value item. For example, they are maybe greater in percentage of items than class A. However, the revenue generated is lesser than that of class A. That is only they're creating maybe 80 to 95 means about 15% revenue, but they are actually 30% in weightage. That is, they have numbers equal to 30% of the total products, but the revenue is only 15%. Now, if you go to class C, they are very low value products. They comprise the majority of all the products. They comprise 50% of the number of items, but they produce revenue equal to only 5%. So this is how they divide class A, class B, and class C. And so the company would have to understand how to classify their items into class A, class B, and class C, and where to give importance, which to create more finely, and where to produce the improvement. So here we'll do a small problem. You have to perform an ABC analysis on the following sample of items in an inventory. They've given P, Q, R, S, T, U, V, W, X, Y. There are 10 items. They have given the annual consumption, that is the number of items that are being bought every year. And they have also given you the price per unit, that is per unit, what would be the total price of the item. And they have asked you to find out, they have asked you to conduct an ABC analysis and find out which of these products lies in class A, which of these products lies in class B, and which of these products lies in class C. So let's start. As the first step, we calculate the usage value of each item. How to calculate the usage value? You have to multiply the price per unit into how many units have been consumed. That is price per unit into the annual consumption. If you multiply, you will get the usage value of every item. So this is a table that I've made. Items are listed from P to Y. This is the annual consumption. This is the price per unit. So the total usage value would be 300 into 10, 3000, 2800 into 15, 42,000, 30 into 10, 300, and so on and so forth. We have calculated the usage value of all the items. The next step would be to rank the usage values in descending order. That is, the maximum usage value would be ranked as the first, and the minimum usage value would be ranked as the last. And I'm going to calculate the cumulative percentage of usage value. So I'll show you a table here. So I've ranked the items as their usage value. You can see the usage value of Q is 42,000, of U is 22,000, and goes on till T, that is 200. And I've also numbered these items cumulatively. Q is item number 1, U item number 2, X item number 3, and T is item number 10. The percentage of item Q is 10%, U is 20%, X is 30%, V is 40%, so on and so forth. This is the percentage of the items. Now, I've arranged it in the descending order of usage value. Now I'm going to add up the usage value. I'm going to accumulate the usage value. This is 42,000. This is 42,000 plus 22,000 is 64,000. 64,000 plus 9,000 is 73,000. 73,000 plus 8,500 is 80,500, and so on and so forth. And finally, the cumulative usage value is 94,300. So the percentage of cumulative usage value would be 42,000 divided by 94,300, 44.54 percentage. 64,000 divided by 94,300, 67.87 percentage. 73,000 divided by 94,300 gives you 77.41 percentage, and so on and so forth until 94,000 divided by 94,000 will give me 100 percentage of the cumulative usage value. So this is how I've calculated cumulative usage value, and I've calculated the percentage number of items. Now these two are the columns that are required for the further analysis: the percentage number of items and the percentage cumulative usage value. Step 3 is to plot the percentage items versus the percentage usage value on a graph. So on the graph I'm going to plot, and here you can see that I've plotted. After I plotted, I can actually see the three different classes. So from the curve, I'm going to identify classes A, B, and C. Under class A, I have identified items Q and U that correspond to 44.54 and 67.87. So the first 20% of the items correspond to 67.87% of the usage value. Class B includes items X and V. They include 20% of the items but have only 17.5% of the usage value. And class C includes all the other items which are S, W, P, Y, R, and T. They comprise of 60% of the items but only correspond to 14.63% of the usage value. Now these are my divisions. Your divisions can change. For example, class B, maybe you can extend up to 91.2 or so on and so forth. But however, this is how you divide between class A, class B, and class C based on the given information. So these are the different salient features of classes A, B, and C. Class A, accurate forecast of quantities are needed, whereas only approximate forecast of quantities are needed in type B, whereas there is no need of forecasting, only rough estimates are sufficient in type C. For purchasing item type A, involvement of senior level officials are required, middle level officials are required for purchase of item C, junior level for purchasing is required for item C. Ordering is based on a requirement basis, that is, customer orders first and then they provide the requirement first and then we will give our ordering. Then item B can be done on an EOQ basis, whereas item C can be done as bulk ordering, because you're sure that there is going to be a lot of orders, there is going to be a lot of demand, and even if we have some amount in extra, since they deal with very little amount of money, or they generate very little amount of revenue, it will not be a big issue. Then enquiries for procurement need to be sent to a large number of suppliers for item type A. Enquiries for procurement need to be sent to 3 or 5 reliable customers to item type B. And quotations from 2 or 3 reliable customers are sufficient for item type C. In item type A, strict degree of control is required. In item type B, moderate degree of control, whereas in item type C, it's a relaxed degree of control, preferably monitoring on a quarterly basis. Safety stock is very low for type A. Safety stock is moderate for type B, whereas safety stock is adequate for type C. So these are the differences between class A, B, and C of your ABC analysis curve. These are some questions for self-assessment. We have been asked from previous university question papers of Kerala Technological University. By going through these questions, you will be able to understand whether you actually understood the topic completely. So I hope you have understood the topic. Thank you for listening.